Hello, my name is Sara di Bartolomeo, and today I will talk about using large language models, ChatGPT in particular, to apply graph layout algorithms. So last year I was reading Hacker News and I stumbled across this blog post from a guy named Jacob Brazio. This was September 2023. He was describing an experiment he ran where he would try to do pathfinding on a graph by describing the problem to GPT-3. Here on the left you can see his prompt. He was trying to get GPT-3 to find the least costly path on a series of networks that look like this. So the numbers here are the weights, so you want to find the path between one node and another that gets the least sum of the costs. His results were actually pretty impressive. He tested the approach on 1,000 graphs, and not only the solutions were valid for the vast majority of them, but so many of them were actually optimal. Now, admittedly, these problems were pretty simple. According to the blog post, they had 3 to 14 nodes and up to 25 edges. But just a few months later, AI was exploding in popularity, and the developments were going at breakneck speed. ChatGPT came out around September of last year, and we started noticing that we could get it to follow some simple instructions, that we could explain a task to it and have it follow the steps. If I explained a simple algorithm to ChatGPT in a simple steps, I could get it to follow it. So this got me thinking, can I apply this to my own field, which is a very algorithmic field, graph drawing? Can I make the AI apply a graph layout algorithm? So a graph layout algorithm is an algorithm that positions the nodes in a graph on the plane. It does so trying to optimize a few criteria to improve readability. And there are many of these that optimize for different things in a graph. Some are for large graphs, some for graphs with certain features, and so on. You need a graph layout algorithm to draw a graph in a proper way so that it's easy to read. Or, as ChatGPT likes to put it, nodes and edges flow, graph layout algorithms show, structure in chaos. So what I wanted to do was explain an algorithm to ChatGPT and get it to apply the steps on its own. Sure, it doesn't do math very well, but how bad would it be? What's the best way to explain an algorithm to it? How do I go about this? So basically, my objectives were explain a graph layout algorithm in natural language to ChatGPT and have it applied to a given graph problem. And the question I had was, given that we know it's going to have issues, can we still obtain a viable graph drawing with it? Now, note that I said in natural language. We all know that ChatGPT can write pretty impressive code, but having it write code that we could then paste into an editor and run wasn't very interesting. I wanted to see if I could get it to apply the steps on its own. And moreover, it all looks simple and easy to us computer scientists, but it's not actually like this for everyone. We tend to forget that there are a lot of steps involved into doing actual computer science. How cool would it be if someone with no coding experience at all could just ask your AI, okay, can you show me the network of connections between this and that, and receive a proper drawing of it? So let's take a look at the experiment we run now. So there are many ways to explain a problem to a language model. The study of how to properly phrase stuff is called prompt engineering. We tried 3 different methods to request for a task to be solved. One is to just straight up ask directly for it. The second, which we called steps, works by splitting the task into atomic subtasks and ask the model to solve them one by one and write the result down. Working on the simplest possible operation helps the model not get confused. And the third, which is called in-context learning, works by giving examples of similar tasks and giving the correct solution as input, and then asking the model to do the same thing on a new problem. So as I said before that I wanted to explain a graph layout algorithm to ChatGPT. Among all the layout algorithms, Sugiyama is perhaps one of the most famous ones. It works in steps. It starts from an input, then there's rank assignment and cycle removal. Then the insertion of dummy vertices, the sorting of nodes within ranks, the straightening of the lines, and finally the result. From these steps, we took only a few ones, the ones that would be fundamental to get the bare bones of Sugiyama, the most important ones, plus 2 additional utility things that would be needed anyways to apply those steps. So we ended up selecting 4 tasks that we wanted ChatGPT to solve. rank assignment, node sorting within ranks, counting the total edge length, and counting crossings. I won't go in order, but I will start from one of the easiest to explain, counting crossings. So we give an input graph and we want ChatGPT to be able to count the edge crossings. In this case, there are two. We want the number of crossings to be returned from ChatGPT. So I'm going to show the prompt that we used for this first task, but I'm not going to show it for the other ones as it is just a wall of text to read. So this is the standard version of the prompt. We have the description of the problem with the description of what nodes and edges are in the graph and how they are sorted within layers. The task we want to be solved is here, which is count the number of crossings, and finally some instructions, some final instructions. And this is an example of what answer ChatGPT would give to a prompt like this. This here instead is an example of the steps version of the same prompt, where you can see that the task is split in multiple tiny subtasks. And this last one is the in-context learning version, where we give examples of the same task on different graphs already solved, and then ask ChatGPT to solve the last one. So now, running the experiment on 50 graphs gave us these results. In-context learning was the method that performed best and returned 80% correct solutions, which means that ChatGPT was able to count the number of crossings correctly. The other methods performed less well, but 80% good results with one of the methods is not bad at all for the trust that I had in the mathematical capabilities of ChatGPT. Next, I wanted it to count the total edge length. So assuming that there is a distance of 1 between the different layers, how long is the sum of all edges? So surprisingly, on problems where edges were always connecting one layer to the next, so wherever they could not jump over layers, ChatGPT had a 100% correctness rate. But having such good results wasn't very interesting. So we scrambled the nodes around so that edges could be longer than just one. And it went much worse. The one that performed best was steps, in this case with 25% correct answers, and the average error on the incorrect answers was around 3. So now we go into the more complicated tasks. This one is a rank assignment. Basically, starting from a non-layered graph, Sugiyama organizes and aligns the nodes in layers that you can see on the right. Sugiyama has a specific method to do this so that the rank assignment turns out properly, but we simplified the task and selected a root node, then basically asked ChatGPT to run a breadth-first search, starting from the root node and assigning to each node a rank that is equal to the minimum distance to the root. So this is the percentage of nodes that ended up being assigned to the correct ranks. In most cases, ChatGPT was able to correctly assign more than half of the nodes to their correct ranks. And note that this is much more correct than a random assignment. If we have 5 possible ranks, a node has a 20% probability to be assigned to the correct rank. So the average for 5 ranks with a random assignment would have been 20%. So we are getting good results. ChatGPT is understanding the task and managing to run it okay. Finally, one of the most complicated tasks, sorting nodes within ranks. In Sugiyama, nodes are moved to the median position of their neighbors in iterations, and this helps a lot in solving crossings. You see it in the picture. There were 2 crossings that were solved by rearranging the nodes. So this is exactly what we asked ChatGPT to do, minus the iterations. We asked it to run a single iteration. And it did okay. In-context learning and steps performed better than standard again. Most of the solutions it gave were either equivalent or worsened, and only a few were improved. In most cases, it is able to apply the steps one after the other, and the main problem is that it required a little more complicated math, and since it is a probabilistic model, math is not its strong point. Here's an example of a graph layout that was a good output from this step. It improved the layout from the initial input and got the number of crossings from 7 to just 2. So let's discuss a little the pros and cons of this approach. Issue number 1, we can't trust the results. Being a probabilistic model, it returns the most probable result, not necessarily the correct one. And it does so with facts and information. Sometimes it invents things, and it does so with math as well. In the context of layout algorithms, there is no way to prove that a return solution is good unless we have access to the ground truth or we have another way to compute the results, thus strongly limiting the purpose of asking ChatGPT. Issue number 2, there is an infinite amount of ways to describe a problem. Which one is going to give us the right solution? Which one is the one that works best? This is too many variables to factor in. We tried these 3 prompts, but it could have been more. So I can't guarantee that the way in which we gave our tasks to ChatGPT was actually the best possible thing to do. And issue number 3, there is a limited number of words we can give to ChatGPT. And this automatically means that the graphs we can handle with this approach will have to be pretty small. However, all these problems are being solved, and the capabilities of large language models are improving every day. The size of the input is being expanded. The models can now use APIs that they can use instead of running them out on their own. The progress in this field is going so fast that we can definitely see a future where asking ChatGPT for a graph drawing is viable. Already, when we submitted this paper, there was ChatGPT 3, and now this is already kind of old. Now we have ChatGPT 4 and models that can access the internet. The results we obtained weren't perfect, but they were all properly formed and not always that bad. So it is true that I can use it to have a drawing, just not as good as I would obtain with running proper code. So a super brief summary that might anticipate some of the questions that you might have at the end of this talk. Can you obtain something that can be called a graph drawing with AI? Yes. Is it better than running code I wrote myself? No. Will it be better in the future? Probably. So many thanks for listening to my talk. You can find all of our prompts and experiments at this URL, and I leave you with a poem about Sugiyama. Many thanks. Bye-bye.